Hello, this is a short summary for numerical analysis. So let us consider the system of linear equation Ax equal to b where A is an n into n matrix. So there exist two different types of solution methods called direct methods and iterative methods. Important points about direct methods are they deliver exact solution in the absence of rounding errors and they are very expensive when we deal with large systems. And for iterative methods, they deliver approximate solutions and they are less expensive while dealing with large systems. In this chapter, we will discuss Jacobi method and Gauss-Seidel method. So what is the definition of iterative method? A method for solving the linear equation Ax equal to b is called iterative if it is a numerical method computing a sequence of approximate solutions xk that converges to the exact solution x as the number of iterations goes on increasing, that is k goes to infinity. So let us look into a general idea for deriving an iterative method. So let's consider Ax equal to b. The idea is based upon splitting the characteristic matrix A as p minus n, where p is a non-singular matrix. We substitute p minus n in plus of A and we get px is equal to nx plus b. And then we have to assume a suitable guess called x0 and we develop our iterative scheme. Xk plus 1 is equal to gxk plus v, where g is called the iteration matrix. So now let us look into Jacobi iteration method. So in Jacobi iteration, we split A as L plus D plus U, where L is the lower triangular entries of A, U is the upper triangular entries of A, and D is the diagonal entries of A. So we substitute L plus D plus U in place of A, and so this is our iteration scheme. Xk plus 1 is equal to minus D inverse L plus U xk plus D inverse B. And the same thing is written in component form, and the expression is something like this. So now let us look into Gauss-Seidel method. This is a component form of Gauss-Seidel method. The only difference here is that we have k plus 1 instead of k, which means that instead of using values from previous iteration, we can use recently evaluated values. And the same thing is written in matrix form. So now let us look into an example. So this is a system of linear equations and we have to compute x1 after one Gauss-Seidel and Jacobi iteration. First we will do the Jacobi method and this is our initial guess. So here we have xik plus 1 is equal to 1 by aii. So this aii, so when we are calculating x1 we have to take a11 which is 5. So x1 will be equal to 1 by 5 and 13 minus y0 minus 2z0, and we will put y0 as 1 here and z0 as 1 here, and we will obtain the value of x1. Similarly, we can obtain the value of y1 and z1 as 10 by 3 and 7 by 4. Now let us do by Gauss-Seidel method. The first step will remain same. The calculation of x1 we will obtain 2, and when we are calculating y1 we will use the recently evaluated value of x1 and we will get the value of y1 as 3, and when we are evaluating z1 we will use the value of x1 and y1 and we will get the value as 1. So these can also be solved by using the matrix form method by calculating the iteration matrix and then doing multiplication.